Our second tech talk today is on the subject of stone and Turkish stone in particular. And this talk will concern the way the material is being used, new techniques, the things that can be done with this remarkable and historic material. And I'm going to pass over the chairing of this session, who will then introduce the speakers, to Gökhan Karakus, the founder of Endia Design. Gökhan, welcome.
Thank you, Paul. So I want to thank Paul Finch for the introduction and to the World Architecture Festival this year for making an effort to create this conference. Today, we wanted to speak as representatives of architects working in stone. And we have two architects with us today to discuss their projects in a session that will last about 40 minutes. They'll discuss their project in 15 minutes. We have Gökhan Avcıoğlu and Nizam Kızılsencer. But before we meet with architects, I'd like to show a little presentation regarding our sponsor, which is Turkish Stones, representing the Turkish natural stone industry. The Turkish natural stone industry in the brand name Turkish Stones has been active since the 1970s, promoting Turkish stone throughout the world. Next slide. So can we have the next slide? Thank you. The Turkish natural stone industry is here in this quick film. You can see some of the details about what we're doing. Sound? So the Turkish stones industry, Turkish Stones is a brand of the Istanbul Stone Exporters Association, which represents the Turkish stone industry, promoting the wide and deep sources of natural stone here in Turkey, which we know as the homeland of natural stone and the homeland of natural stone and architecture. Today to speak about their projects working with Turkish stone in terms of their design, technology, and innovation, we have two architects. The first architect we have is Gökhan Avcıoğlu. Gökhan Avcıoğlu is the principal and founder of Global Architectural Development based in Istanbul, with activities also in New York, London, and Moscow. He is a graduate of Konya Selçuklu University in Turkey. And from 1990, he has been the principal and founder of Global Architectural Development here in Istanbul. We also have Nizam Kızılsencer. Nizam is a 1996 graduate of Istanbul Technical University in architecture, and then Yale School of Architecture, EMARC, in 2000. He was senior design leader at Skidmore, Owings & Merrill in New York, and later he was the co-founder and principal of Strata Architects. Today he is the principal and founder of DIA in New York. So these are our two speakers. I'm Gökhan Karakus. I'm a designer and an architectural critic focusing on natural stone industry here in Turkey, but worldwide. This is an industry that's going through some important changes because of digital fabrication, computational design, and advances in technology. So we'd like to show you a little bit of that today. Next slide. So our agenda consists of looking at important projects dealing with natural stone, some examples in facades, cladding, and then also looking at how digital fabrication works in natural stone. Digital fabrication, robotics, CNC, this is an important part of the industry in Turkey, which is a very rich and wide source of natural stone, but importantly, can take that natural stone and transform it into the different designs that architects create around the world. Next slide. So these developments in terms of structural stone, in terms of facade techniques, and also in terms of looking at digital fabrication, looking at how computational design has affected stone fabrication and stone architecture. That's what we'll look at today. And let's turn it over to our first speaker. Next slide. I think it's the last slide. Yes, thank you for this to Turkish Stones, the Istanbul Stone Exporters Association, part of the Turkish Exporters Assembly, for sponsoring our talk. Thank you to the President Aydin Bey, who's hopefully listening to us, and all to the board members and the members of IMI. Okay, so our first speaker is Gökhan Avcıoğlu. Gökhan Avcıoğlu is going to talk to us about both his built and also unbuilt work in architecture and stone here in Turkey and in the region. So Gökhan?
Yeah, okay. Thank you very much. First of all, special thanks for this opportunity to you and to VAF and also the Turkish Stone Organization. And I appreciate that. First of all, I would like to add some information, because you showed us a short video about the Turkish stones. I think I have no idea about what is the Turkish stones, but always I would like to talk about the Anatolian stones, because I would like to add not only the Anatolia history, also our architecture and urban history starts from the 12,000 years before, from Göbekli Tepe. And I don't know why today's Turkish Republic and Turkish people prefers starting from the Süleymaniye, from the great architect Sinan or the other one. And first of all, is very important because I learned from many things from the Greek architecture, Greek ancient architecture, and also the Roman architecture. I feel I'm a Mediterranean architect, and also I feel about me, it's not only Mediterranean architecture, also Roman style architecture means I would like to follow the many things from our different civilization from everywhere on our planet. And stone for me, it's not only the material, also the feeling about the daily life, feeling about the nature. And Anatolia, the very rich, highly rich country, as I listed almost 89 different marble, different stones from anywhere on Anatolia. If you dig or carve or find any small stones or big stones, always I would like to think, and please next. And actually, I would like to. Yeah, it's you can next every 5 seconds if you don't mind, please. And also I like to work on the architecture and with stone, because stone is what I explained to you, the 12,000 years old fantastic material, and also not only material, also statement tool for architects. What does that mean? The structural statement, you can do something with the structural statement with that material, and also as a material do something, and also technical statement, and also art statement, what we need as an architect to do something for our civilization. Actually, let's say the first of all, I think, because when I was a small child, visited with my family, and then took them to visit some sites, the antique, ancient heritage spaces like Ephesus, and also the Milet and Priene and the Bergama. It's a different kind of and also the Cappadocia, and really influenced that kind of places, and then and the site to do something for people, or our civilization, or also explain to myself. Yeah, actually, and you can follow the all slide, please. The picture is, please, next. Okay, what I explained before. So you can see the designing something, building something or adding something on the planet, our planet. It's a very complicated issue, but the end of the game, as an architect, we would like to explain ourselves, our civilization, and then and also our idea with that kind of the statements. The stone helps to you to do something, and explain your something, and explain your civilization, explain your idea to next generation. It's because the stone, normally 30 million years old material, not yesterday's and then the last week producing by machines. It's a totally nature, and gives you idea. Please next, please next. You can continue. And today we are interesting about the evolution, not only the architects and any statement about the ego, not the ecological things, but we are interested in about the evolution. I would like to show you some our projects, what we do, what we did. Please next, please next. And we are looking for now on the pandemic time, what is the next our future cities and our dwellings. Please next. Next. And the first project is about the one in Ortaköy, Istanbul, in the middle of the Ortaköy, in the middle of our Bosphorus and our city, surrounded by nature. Please next. And what we did, created an architecture, and making an architecture, and finding a form, and designing not only the building, also giving to nature what we add our planet, also as a big garden on the top. We use that as material. It's the Turkish stone, let's say the Anatolian stone. Also, I prefer the Anatolian stone. The name is the Ünye. Gökhan, will you follow me?
Try to go through this a little bit faster. Maybe Toby, if you can go automatically, just switch every 5 seconds.
Yeah, let's go to the other pictures, please. You can see the we made and not only the housing projects, also we created an envelope. Maybe it's not only the envelope, also an envelope also gave to our architecture as in not only the shape, also a garden and 30 million years old face. You take next, please. Next, please. We use that kind of the projects. Some tools like software tools, also the make modeling and physical modeling, and also digital modeling. And what we try to do, the giving the more daylight, and also giving more daily life to not only the envelope, also on the top of the building. You can see the sustainable life for our residents. Let's forward to the other projects, I think, because time is clicking. There's another project is in the New Wada, at in same city in Istanbul. Also, the first was in European side, other was not. It's coming now the Asian side. You can see fantastic view, and also we try to building giving a shape, not making form, creating the inside more light, more daily light, more view to directed to sea, and then are the Prince Islands. You can see the two buildings, different shape, some details about the facade systems, and more. You know, we discussed in Istanbul, what is the Istanbul weather conditions? How can we design that like a New York or the Miami? Means New York is the chilly, and it's not easy to create the balcony and outside life. But the Miami has the opposite, and Istanbul in between them. Therefore, we try to different alternative solutions. The balcony, but protected, but not like a New York, not like a Miami, in between, let's say. The third project is about the Cappadocia.
Gökhan, if you can wrap up in the next minute or so.
Next. Okay, next. It's the Cappadocia is a fantastic place because existing conditions is fantastic, totally made by stone. We try to, you can click to our website and you can see some details, the amazing historic area, and also the earth is totally made by nature. And we try to using the same materials and the nature materials to design something.
So here we can see the Anatolian, the wide, and deep varieties of natural stone here in Anatolia and Kayseri. We have this volcanic type stones, the basalts, and here the different limestones working together.
Exactly.
Okay, I think we can wrap you up, Gökhan, this last project, and we'll move over to Nizam. Okay, thank you, Gökhan Avcıoğlu. We'll come back to you and ask in a question and answer session. Thank you. And now we open the floor to Nizam Kızılsancar of DIA in New York to talk about 2 projects he has realized in New York with Turkish stone.
Hello, everybody. By the way, my screen just went a little bit blurry. I don't know if it's the same on your end, Gökhan, but I just...
it's a little bit blurry, yes. Yeah, it's a little bit blurry. But go ahead if you can manage. So can we get the slides up, Toby? There we go. I think you need to switch to Nizam from Gökhan. There we go. Go ahead, Nizam. I think that's your first slide. We can see you on the slide now.
Okay, so actually the first slide was the one before this. Can we go one back?
There we go.
Yes, thank you. So this is our project in Red Hook, Brooklyn. This is a manufacturing building. And here in this aerial view, you see Manhattan, downtown Manhattan in the background. Red Hook is a very industrial neighborhood. And when we were asked to do this manufacturing building here, we approached in a way that we could utilize a material that could be robust and can also endure not only the industrial city itself, but also the changing nature. New York City lately started having some hurricane alarms, alerts, and we thought that we should be actually careful about this building as we design it, because Red Hook is in a flood zone, in a hurricane evacuation zone, and this building actually should be quite resilient. Next slide. So first thing we did is actually because it's in a flood zone, we hovered the tenant floors and put the parking on the ground floor. And when we looked at the building, we had one more utilitarian side of the building, the core pushed to the side, and then the occupant floor plates we create like a box, kind of like hovering above that vacant ground floor. And we thought of this box to be a little bit more porous. We wanted to bring some porosity to it, but at the same time we were thinking of like using this resilient material. Next. So two going in hand, we sort of like look for this kind of inspiration in nature, like this material that we could use on the facade of the building, which is basalt. We were inspired with. We looked at the basalt columns in nature and how we could actually almost use this as a reminiscent of our facade, how it could be more porous to more opaque in this kind of vertical rhythm that we could create. And basalt is also, it's been used in manufacturing, in industry. It's something that relates to this building. Next. Well, we actually looked at basalt and the Dia base and gabbro. These are like Dia base and gabbro. They're intrusive igneous rocks. Basalt is extrusive. We end up using Dia base because of the color that we want to blend with other colors that we want to use in the building, such as like highlighting the exterior stair in red color, which goes really well with the Dia base color. Next. So you can see the exterior stair in red color, and we also like continued this contrast with the gray and the shadows and the light and the color, how they can actually create these vibrance. So like one of the feature elements is the Howard ceiling at the ground level. But we didn't stop there. We just took it inside, where we also introduced color. Again, another feature element is the interior circulation, heart of the building inside. And we even got carried away. Like we were like looking at some colored shadows on the CMU blocks of the garage. We made it like three-dimensional, and we tried to see if we could actually see the dancing shadows and make them in color. But going back to the facade, as I was saying, we were looking for something resilient, and the material itself, basalt, is resilient. But like the cladding process, the traditional cladding process of thin veneer stone cladding, is not that resilient. It actually stone, even though it has enormous compressive strength, it is very brittle, especially against wind loads, earthquake, or other blast related forces. It's very fragile. And also, like to kind of combat against this fragility, the bad thing we do is actually we increase the thickness of natural stone. And I always believe that that's actually kind of like a unresponsible way of using stone, as it is not a very it's not actually a renewable material. At some point, we will actually consume all the stone on Earth. So how to use stone more responsibly, and I always like the approach where when you can use the material its most minimal amount. So we went with using an ultra thin Dia base, a 5 millimeter thick, and it was bonded to honeycomb backing, reinforced by honeycomb backing. That allowed us to create a very light stone cladding facade. Also create a larger cavity where we could have adequate insulation in the cavity, rather than having that behind the substrate. So you see the assembly of the ultra thin stone layer adhered to an aluminum plate, then bonded to honeycomb, and at the back again another aluminum plate, and then this is by clips hung on to the horizontal struts, and then the vertical strut is connected to the brackets, which is also connected then to the metal stud wall. This is a very light system compared to the traditional use of thin veneer stone. Usually you gotta have 3 centimeter or 1/316 inch stone by robust steel brackets anchored to a masonry CMU wall, or very heavy duty steel substrate. In this case, we were able to put the light stone panels directly onto the metal stud wall in our building. Just to show you in comparison, this is the traditional stone cladding, where you actually use mechanical fastening, and the brackets are anchored either to the CMU wall or to a steel framing system at the back. And usually when you use a conventional system, it's always safer to go with granite kind of materials, marble or travertine is suitable for climates where there's heat differentiation seasonally, also throughout the day. So it's kind of constraining. So you always kind of like use granite almost always for the facades. But if you use it as an ultra thin veneer with honeycomb backing, you can go back to using travertine. You can go back to using marbles that you were not able to use. What you see on the slide here is the Finlandia Hall, the concert hall in Helsinki, designed by Aalto. Some people think actually it's an amazing facade, very three-dimensional, but that's actually that's the failure of marble, where it doesn't contract back and it just kind of starts warping. And that's one of the issues with using stone cladding, marble stone cladding on the facades. The other issue, as I started saying, is wind. The earth is rougher than 10 years ago, especially in New York City. We start realizing that the buildings have to be much more resilient, especially against wind-related forces. And you know, if you look at Manhattan and also the other boroughs, you know, the wind is always an issue. Like this is actually the map is showing the historical tornadoes. Like in 2007, Category 2 tornado actually caused quite a damage in Brooklyn.
You said we got 2 minutes.
And what if it's actually something more than Category 2 tornado? Well, it's a hurricane. Like when we had Sandy that made a landfall within the vicinity of New York City with Category 1 hurricane, it caused enormous damage. So it shows that the buildings and the components of the buildings need to be ready for this. That's why I'm always like taking back to this, like why it's actually it was the right decision for us to use honeycomb-backed ultra-thin veneer stone. I think that's again it's much more resilient. It's 60 times up to 60 times stronger than conventional thin veneer stone, and you can increase the amount of type of stones you can use at the minimum amount. This is something also important for earthquake loads. Even in New York, there's small to moderate earthquakes, and it looks like it's going to be increasing. And for that, Tony?
Go ahead, Nizam. Go ahead, Nizam.
Yeah, sorry, I heard something. So the more important thing about the use of ultra thin veneer stone, you could actually wrap it around structures in a much lighter manner, and you can create depths kind of similar to the ancient buildings. You could actually have overhang soffits. So that's why we in one of our recent projects, this is in New York City, we're studying a facade where we like to use stone, but also we like to not use it as a kind of like a surface element, but create that depth that belong to the times where stone actually created shadow and brought depth to structures. And so it's kind of like bringing us back times where the use of stone celebrated almost in the masonry sense, but while we're using it in the most minimal amount possible. Thank you very much.
Thank you, Nizam. So we have about 4 minutes left for questions. I'm just going to ask a really quick question here, Nizam. Nizam, so you use this basalt diabase for your building in New York. in terms of its environmental performance on that facade. Can you speak a little bit about both its insulation properties, but also in terms of how it's resistant to urban pollution and other elements that create degradation, as you correctly pointed out?
Well, the thing about the stone, it's even though it's in its most uniform condition as a basalt or diabase, these are really dense stones. So you don't really see like surface stresses or fractures, but even these stones in time could actually fail due to temperature differentiations. So using a honeycomb backing takes that stress away from the stone. So in a way, the stone is actually reinforced. It's kind of like, you know, reinforced concrete, or like you can even compare that to like fiberglass reinforced concrete. So
right.
like
but it's a
honeycomb
natural
actually,
material, so you get product. Yeah.
so but again, like for the exterior of the stone itself is a very durable material. You know, actually using stone helps us to reduce amount of required cleaning on the facades. It actually that aspect of stone is actually very sustainable. Using stone actually reduces amount of cleaning, amount of other maintenance related issues. But then stone needs to endure like the way the ancient buildings endure the time.
Okay, thank you. And that the basalt was sourced from, I believe, Kayseri in Anatolia, correct?
Yes.
The basalt. Okay.
But again,
So
I think we looked at basalt, but for color we went with the diabase, which is kind of like a far relative of basalt.
Right.
We
Also an
like the
Anatolian
color of
stone.
diabase better, but diabase is kind of like granite without quartz. You know, it's also a very dense stone.
Okay, and the last question I wanted to Gökhan Avcıoğlu, we got about a minute left. Gökhan, can you speak a little bit about Cappadocia and what was inspired for those interesting Cappadocia projects you showed in terms of the history, but also the kind of volcanic and limestone that we saw in your project?
Thank you. Actually, as an architect, I'm not only interested in the envelope. Also, envelope is not the first definition for me. And also, I would like to try to volume and also making a form and also making a space.
So that's what you tried to do in the Cappadocia project.
Yeah, when I was a child, and then I took my family showed me some places and spaces, and that kind of the made by the stone. And the totally stone is in the carving in one mountain. And
okay. Thank you very much. I'm sorry, we got 20 more seconds left, so I'm going to have to close the session. I want to thank Gökhan Avcıoğlu and Nizam Kızılsancar, who showed us possibilities of Turkish stone in different climates, different regions, Istanbul and New York. And Turkish Stones is promoting the use of Turkish stones internationally because of the wide and rich varieties we have here in the land of natural stone. Thank you.
And thank you, Turkish Stone. Thank you, the two Gökhans. Thank you, Nazim, for a really interesting presentation about a material which is both historic, but as we also saw, is capable of use in very thin-skin, high-tech circumstances. Thank you very much.